this video, we move to the number 4 chapter for this calculus problem solving. For this subchapter is we will talk about the function derivative. So that is the initial the parts for this calculus from. And we will discuss two parts. Is one, we will use this derivative, the concept to build our derivative calculator. And then this, if you have multiple variables, we need to have a way to calculate the partial derivative. So that is the two parts within this subchapter. So first is let's try to familiarize what the Python and the SymPy provide you to calculate the derivative. From the definition, derivative of a function express the rate of the change. So if you have this function is x squared 2, so the derivative of x squared 2 will be the 2x. So that is the calculation, and within the SymPy is quite convenient. Is it provide you our derivative class that we can directly use. So let's from SymPy. So we already import simple last video, so I haven't quit from Python, so we don't need to import simple again. So we just use this derivative class. Then we define the symbol t. So let's verify t is a symbol now. And we have this one, the st as this output set with these rules. So 5t plus. So you can use this t times t and times 2 times t and times the 8. And then we can directly use this derivative. Use the st is the output function, this range, and the t is the scope. Then you get is we have a derivative of this one for t or based on t. So if we after we import this, we can use this to have a derivative, the symbolic expression. And if we want to make the calculation, then we just use this DOIT, this method. So, and we first is we assign this to our variable. Then you can see d is this derivative expression. Then we put this d DOIT with the empty the arguments. Then 5t the squares. This part is for our multiple parts is the derivative is just 1 by 1. So first this is the this square is down to this multiplication. Then 5 times 2 is 10 as this coefficient, and the t square downgrade to t. So it's the 10 times t. And 2 times t will be just remove this 2, so that is 2. And constant, our numbers derivative will be 0, so that will be the 10t plus 2. So that we go this. And if we want to bring some the value to this derivative, then we just use the subs method. So we have this derivative, then we go to subs, and then we can replace t using our dictionary format is t replaced by t1. So then we get our another expression, but now is with our specific this the variables, and if we replace that by our number, then it's calculated 10 times 1 is 10 plus 2 is 12. So if you put that is maybe it's different, then they just calculate a different result. So this is one single the variable, the derivative, and if we have our it's just have this plus, and if we have a single variable but we have the multiply, so this will be our complicated the expression in the function. So we can also try to see this one because using the derivative, no matter it's complex or simple, we can just use that to make the calculation. So first is we define symbol. And then this we put our function. So we just try to use a symbol to define function. So first is square to 3 time this and then the square 2 plus x, and then times x square 2 plus x. So that is our f. So it's will be deduced or the simplified by the internal rule. So that's fine. But what we will do is we put this new d is to the derivative, and we have the f, and then we put this f over x. So now it's a d. You can see it's the derivative, and what we can do is d dot will be this. It's more complicated, but it's already calculated. So if we put this one is like this x equal to 2. Oh, so subs. Then is we just replace x by our the figure or the numbers, so you can get this calculated. And if we see is x will be our another the variable, so x is x plus 3. Then you get our just use x plus 3 to replace the original x. So that is the this using the subs, you can make the calculation. So using this way, is you see we use the terminal to input different expression, but the common thing is this one you define our deviation and assign that to a variable. Then we use this dot to calculate deviation, and then this we use subs to transfer the arguments to the variable, then get this the actual result for the deviation calculation. So some steps can be reused, and we can extend this to our more common. We call this derivative calculator. So let's starting to make our first code for this chapter 7. So let's quit from Python, and now we are in chapter 7. So let's make our new file. So it's now we already is 050704 is 1 is derivative calculator. Py. So what is our the calculator do is it will take a function as input. This function will be our expression or with this the symbolic, and then print the result of the differentiating in it with respect to the variable specified. We can put that, and then we use subs to print out. So we can see here. So let's make our header. So purpose derivative calculator, and the author and the date. Yeah. So let's put this to see is of main program. So we will ask people to enter a function. So that is f. We will put that. So this can be a string. So we just ask people to enter our function expression. And then this we also is input our variable that we will use to calculate the and the input enter the variable to differentiate it with respected to. So let's make that bigger. So we got f and we got this variable. So that is the two arguments we need to transfer to the derivative function. And let's use the simplify. So the simplifiers can help us to make those the validation. So from simply import the simplify. So let's ensure is we just use the as needed as possible. So try f is simplify f. So if that is have issue, so we also need arrows. So from I think it's I remember is a simplify arrow is already in the simply, not in the code simplify. So that is a newer version. So simply. So we can directly use that except simplify arrow. Oh no. So print invalid input. And then finally else we will do the derivative. That is our function, our own defined function. So we use this small case, not that the standard one. So looks like it's so let's see. So simplify arrow. So whether it's that can that is indeed is there. So then let's make testing to do this print hello. So if the is verified okay, then is we just print something. So enter expression x squared 2 plus 2x minus 1 minus 2, and x is so that means this validation is correct. So now so far we don't have any the function yet. So now we can starting to define our derivative function with the two transfer in arguments. So this we will do the this derivative. So very easy. So var will be our symbol. So we need to make this symbol import. So we define var is the symbol var, and then we definitely we need this the derivative. So now we can do the calculation. So we assign d is the derivative with the transferred f and the var, and we do this d dot. So then is we have that, and we can print. So when we want to print this, we can use this pretty print. So print. So we can print normal. So d so just directly print this. So we don't need this line. And also let's also do our pretty print. So now we have that, and we can starting to calculate. Let's do this 2 times x times x. So that is same. So plus 3 times x plus 1. So this derivative will be the 4x plus 3. So then this 1 is no matter. So let's see with the variable is x. Now we can see, so normal print will be the 4 times x. The pretty print is change this multiplication symbol to a dot. And then we can make another. One is we have the more higher. So if we see it's 6 times x with 8 and minus 15 times x times 6 and plus the x times the square 4. So this is the square, and then we have x as the this way. So the variable. So normal print is here. So the pretty print, now you can see this the squares or this power number is better. So that is the calculator. Very easy. We just simulate what we have done in the terminal to create this, and now it can accept or validate this function. Then this it will print this derivative result for you. And when we talk about the derivative, is the derivative with the multi-derivative, the multivariable function with respect to any the value. So if I say here, so if I make this one, so it's x 5 times x is 2 and times y is 4 and plus 5 times y times x square with the 3. So if I see x, then it's just the treat is y as our the const. So they don't make that. Is now you can see here is y is have the power is 4. But we only do this derivative for x. So x will be changed to here is 10x. And then this 10x times this one. And this one will be the 2x still have a square. So that is 15 x squared 2 and times y. So when we do this multiple variable function with our calculator, is we need to define the which this variable we are using. So and there's also our code that is a partial derivative. So we can identify this to x, then this y will be treated as our const, or you can see that is not a variable. We can make that to y, then that will be the same. X will not change. So let's see. So if I copy this and make the same, and now is I put this to y. So you get is the different parts, but y is doing the derivative, and x will be kept. So that is the thing. So 5x here is the 2. So 5. Let me see. So here, so 5x, and here is it's here. The y is changed to 1, and here is y is go to the minus 4 minus 1 in the squares. And then this 5 times 4, so 20. So this is we call that is a partial derivative. So from the this Python's derivative class, you can use one single calculator to do whatever the numbers of the variable, but you need to define this derivative is to which variable. So a key assumption I've made in this chapter is that all the function we've calculated the derivative of are differentiable in their respective domain. So if that is not differentiable, you will get error. So we assume is we put some these functions inputs are okay to do this derivative operation. So we started, so we finished this subchapter. Next chapter, we will go to our higher order derivative and try to find the, like this curve, we try to find the maxima like this A, or some is the maxima is the C, so a range for certain range like B and D are, we call this the minimum and the maximum, but we also have the total maxima and the total minima. So we will try to find out some the implementation from Python on such topic. So see you in the next video. Bye for now.